Welcome everyone, I'm Adam. In this problem, for our given vectors u equal to 3 times I plus j, and vector v equal to negative 2 times I plus 4j, where I and j are our unit vectors, we're going to be finding the angle between the two vectors in both radians and degrees. So we'll go ahead and start with part A, finding the angle between them in radians. So to start with, we're going to rewrite these, not that it's too difficult to read here, but we have our vector u. You can write it in component form. So notice in component form we can take the numbers right in front of our two unit vectors. So this can be written vector u in component form with components 3 and 1. And then our vector v in component form negative 2 and 4. Okay. So with part A, so we want to find the angle between these two vectors. Well, what do we know? We know that we can at least start by finding the cosine of the angle between two vectors. So the cosine of an angle theta, where theta is between 0 and pi, again in radians, is equal to, well, the dot product between the two vectors. So the dot product between u and v divided by the scalar multiple of both their magnitudes. So the magnitude of u times the magnitude of v. So from here, we can just jump into filling this out. So the dot product between u and v, again, it's the component-wise multiplication and then adding everything together. So taking the first component with u, 3 times the first component in v, negative 2, and then adding that with the first component in u, which is 1, times the second component in v, which is 4, and then divided by the product between both their magnitudes. And so the magnitude of a vector, again, is the square root of the sum of squares of its components. So for u, it's going to be the square root of 3 squared plus 1 squared, and then times the magnitude of v, the square root of negative 2 squared plus 4 squared. And we'll just simplify this. So on our top, we have negative 6 plus 4, so negative 2. On the bottom, 3 squared plus 1 squared, going to give us the square root of 10. And then negative 2 squared plus 4 squared will give us the square root of 20. Now, this is what the cosine of the angle is equal to. And in a little bit, what we're going to use is the inverse cosine of what we get here to find what the angle is equal to. So for all intents and purposes, we're good to go right now, but we're going to simplify this just a little bit more. So I see that I have square root of 10 times square root of 20 in the denominator. So let's see, we know we can put that together and say that'll give us, say, the square root of 10 times 20, 200, which again I can factor if we're trying to take out a perfect square. I know that's equal to 100 times 2. So what that gives us then is we have negative 2 over the square root of 10, which is 10 times, square root of 100, which is 10, times the square root of 2. And lastly, see, a 2 will cancel out there, leaving us with a 5 in the denominator. So we have negative 1 over 5 times the square root of 2. And so that's what our cosine value is equal to. But we want the angle. So our angle, right, theta, is going to be equal to cosine inverse of this value. So cosine inverse of negative 1 divided by 5 times the square root of 2 . So getting our calculator to take a look at this. And again, we want this in radians, so make sure we're in radian mode. So cosine inverse of negative 1 divided by the quantity 5 times the square root of 2 gives us approximately 1.7 And that's in radians. Okay, so that's part A. That's our angle between the two vectors, u and v, in radians. And now we want to find the angle in degrees. So there's two ways to do this. Since we have our calculator in hand, the easiest way to do it would be take theta equal to cosine inverse of our -1 over 5 times the square root of 2, where now we're just going to make sure our calculator, right, is in degree mode. Okay. So we switch over to degree mode. And so cosine inverse of -1 over 5 times the square root of 2 gives us approximately, say, 98.1, where that's degrees. Okay. So that's the calculator way of doing it, but then of course there's the other way to do it by hand. If we want to find our angle theta, where we already know the angle in radians. Here we go from radians to degrees. So we have our approximate value in radians, so theta will be approximately our angle in radians, 1.713, and then our conversion times 180 degrees over pi. So if we take 1.713 times 180 divided by pi, and we get approximately 98.1 degrees. So there we have the angle in degrees between u and v, approximately 98.1, and the angle in radians, approximately 1.713. Thank you very much.